I will explain you tube lemma in this video. Here you can see the statement of tube lemma. In a video I have uploaded how to keep the statement of this tube lemma in your mind without any confusions when writing it on in the exam. Okay, so here I will explain the same thing again also. Okay, so here you have the statement. If you memorize, just read it, and if you are trying to memorize it, you may feel difficult or you get confusions, you may forget it. So to avoid all these things, I'm going to explain you a simple thing with this with a figure. Okay, if you keep that figure in your mind, then it becomes very easy to you to keep the statement in your mind. Okay, so first here you have to consider a product space. Okay, here first what you have to do is you have to consider a product space. Product space is x cross y. Okay, here in this product space you are having this y, right? The statement they are saying where y is what? Compact. Under a condition this y is compact. Okay, so under what condition? I will tell you. This y is compact if n is an open set of x cross y. There is an n. If n is an open set of what? X cross y containing the slice. Here in this n, open set n, inside this open set n, you are having a slice of this x cross y. The slice is x naught cross y. Okay, this is a slice of x cross y, and the slice of x cross y also present inside this what? Slice of x cross y is also present inside this open set n. If these conditions are there, then n contains a tube, some tube, that is inside n you will have a tube. Inside n, where you have the tube? Above this slice. Okay, above this slice you will have some tube. The tube is y cross y. Okay, where you have to talk about y w now. This w is a what? W is a neighborhood of x naught. Okay, x naught belongs to this capital X. Okay, this is what the statement. Okay, so let us start telling this again. Okay, using this figure. So here you have to first, don't try to memorize the statement that you have. Memorize the sentences, exact sentences that you can see in the statement. First understand what is there in the statement, then automatically the sentence will come into your mind. Okay, so consider first x cross y. This x cross y is the product space where this y is compact. Okay, where y is compact. When y will be compact? If there is an open set n of x cross y containing the slice x naught cross y of x cross y, then n contains some tube w cross y above x naught cross y, where this w is a neighborhood of what? X naught in capital X. Okay, this is what the statement. Try to study with using these kind of figures. Okay, now let us pass on to the proof of this tube lemma. This is a very important lemma in our topology. So here you can see the statement. Now in the proof, what you have to do is you have to write the given first. Given, that is till this, from this to this you have to given x cross y is the product space. Okay, comma, y is compact if n is an open set of x cross y containing the slice this of x cross y. You have to write till this in your given. Okay, first line of the proof. In the given you have to write all these things. Now you are going to write the to prove. To prove means you have to write this sentence. N contains some tube w cross y above the slice x cross y, where w is a neighborhood of x naught in X naught belongs to where? Capital X. That is what you are writing. So here you have to write this in where? This to true. Okay, now in the proof what you are going to do is, in the first two lines you are just copying what is in the statement, right? So next what you are doing is, you are going to cover our slice. Okay, this is slice, right? In the statement you are having this is slice, you know that. What you are doing is, you are going to cover this slice X naught cross Y. Using what you are going to cover? You are going to cover it with the basis element. What is the basis element? Here U cross V is the basis element. Using this basis element, you are going to cover this slice. Okay, so you will cover that using this basis element U cross V that intersect X cross Y. That is what you will write. Okay, in the sentence you will write, after writing let us cover X naught cross Y by basis element U cross V that intersect our product space X cross Y. Okay, that means what? Our U cross V intersect X cross Y. Okay, and then you will write and contained in N. It means this U cross V present inside where? Our open set N. Okay, that is what you will write in the next first line. Okay, that is you will write in this line. What you have to do? First you have to consider a slice. The slice is X naught cross Y. You are going to cover this slice. Using what you are going to cover? Basis element. Here what is our basis element? U cross V. That there is also happening with this basis element, that is U cross V intersect our product space X cross Y, and this U cross V is present, contained in what? Contained in N. N means what? Our open set. Okay, now since Y is compact, in our statement you are having Y is compact, right? So here from the statement you are writing Y is compact. The slice you have, right, X naught cross Y, that will also compact. That is what you will write in the next line. Since Y is compact, the slice also compact. And then the slice is compact, no? So by the definition of compact, you can take some collection from what? The compact set, right? So that is what you are saying, there exists. That is why here is existing some collection of basis elements. So therefore there exist these basis elements, U1 cross V1, U2 cross V2, etc., UN cross V1, Vn. Okay, these, did I say that right? These basis elements are existing. Now what you have to do is, in the next line implies, when you find the union of these basis elements, inside this basis elements, union of these basis elements, you will have this slice X naught cross Y. How you can say that? I will tell you how. Okay, in the first line you are covering what? Covering our slice with the basis element, right? Here this is the union of basis element. So surely what will happen? This slice will contained in, that is present inside this union of basis elements, right? So that is what you are writing, X naught cross Y contained in this. Is that clear? And the next line, that is here what you are going to do is, you have to keep this in your mind. You are going to say first you have to prove this, right? So now what you are doing is, you are proving W is a neighborhood of X naught in X. That is what you are about to prove. Okay, after proving that, you will prove what? You will prove W cross Y contained in N. Okay, you are proving two conditions here. First you will prove W is a neighborhood of X naught, and then you will prove W cross Y, that is our tube is contained in our open set N. That is our tube is present inside the open set N. That is what you will prove in this proof. So here I hope till this you are clear. And let us move on to the next step. So in this step, what you are doing is, you are taking W equal to the U intersection of this U1, U2, intersection, right, un. Let w equal to this. That is how you are taking. So here you have to know something. This u1, u2, u3, u4, un are the basis elements present in X. Okay, these are the basis elements present in X. u1 cross v1 is what? These are the basis elements present in the product space X cross y. When you write it without y, you are simply writing u1, u2, right? u1, u2, etc. Even this is the basis element of y. Okay, so that is an additional point. Okay, keep that. So let w equal to, write this clearly. This w is open in X. How you are saying that, I will tell you. I told you that u1 u2 are the basis element of X, right? So that is why here you are saying this w is open in X. Okay, I have said you the reason why you are saying X here. Now I will tell you how you are saying open. W is open in X. I will tell you here. You know that u1, u2, un are the basis elements, right? Basis elements are always open. Okay, so that is why these are open in X. If these are open in X, clearly you can say W is also open in X, right? Because both are equal. So that is why you are writing clearly W is open in X in this line. Now, in the next line you will write, since this is not equal to empty, UI cross VI intersection intersection of slice and the basis elements is not equal to empty. Okay, and here x naught, you know, x naught belongs to UI for all I equal to 1, 2, 3, etc. n. How you are saying this? You know that, I will tell you, you know that the slice is present inside the union of these basis elements of the product space X cross Y, right? This contained in this. So when you find the intersection, surely this value is present inside this, no? So you are not going to get empty as your answer. So that is what you are writing. You are finding intersection of basis elements and the slice. You know that the slice is present inside this union of these basis elements, right? So that is why when you find the intersection, you are not going to get empty. So that is why not equal to empty you are writing, since this not equal to empty. Now from this you have to know something. Here x naught, the value of x naught belongs to X. Here you have to know this. This is X, this is Y. Okay, so here in X you are having u1, u2, u3, u4. In common you say u. Okay, and x naught belongs to X. X also belongs to X, and all these values present inside W. Okay, that is what you will come to know when you try to understand the proof more clearly. Okay, so here in the Y you will have V, basis element V, and Y you will have an element Y, that is all small y, that is also present inside our capital Y. Okay, this is what happening here. So here in this line you have wrote x naught belongs to UI. Okay, UI, it means x naught belongs to u1, u2, u3, u4, u5. In all ui's till n you will have this x naught. So that is why x naught belongs to all ui's, right? I am telling you how you are writing this. Okay, the explanation, I am giving explanation for this line, how you are saying this W is a neighborhood of x naught. Okay, so here in just above you have wrote x naught belongs to UI. Therefore, if x naught belongs to all UI means, you know that if x naught belongs to these means, then x naught belongs to W is also, right? You know that W is open in X. Okay, x naught belongs to W, you have told now. If x naught belongs to W, and also you are having this W is open in X, so every open set is a neighborhood. Every neighborhood is an open set. You know that, right? So this is open means then you can say this W is a neighborhood of x naught, because x naught present in this W, just now I told, right? Inside W you are having x naught. So you are saying this x, this w is opening x you have wrote, so that is why with all these you can say now this w is a neighborhood of what? The point present inside this w. What is the point present inside this w? X naught, right? So that is what we are writing. Thus w is a neighborhood of x naught. Now we are going to prove our tube, right? This is our tube that you can see in our statement, w cross y contained in n. That is what we have to prove. Let what you have to prove contained in n, what we will do usually, you will take one element from here and you will say that same element present inside n also. If you say that, then you can say w cross y contained in n. That is what the procedure, right? To say w cross y contained in n, right? So let you are taking an element from w cross y, that is x cross y, small x cross y you are taking. Now from this you can say this x belongs to w and this y belongs to capital Y. Okay, is that clear? Now implies you are considering this only, considering this, and by considering this you are writing the next step. Okay, x belongs to w means, you know that x belongs to this w means here w is intersection of these values, right? Intersection of these values means what? If x belongs to x belongs to w means w is equal to this, it means this x belongs to all these ui's, all these intersection, no? So it present in x present in u1, u2, u3, u4 till un x is present. Okay, so that is why you are writing x belongs to ui for all I. Now what you are doing is this x cross y belongs to this, okay, this element present inside our slice. Okay, so now you have to write like this, belongs to our slice. You know that our slice contained in what? This you have wrote it, right? You are just writing it down this in this step. Now from this you will get, therefore we get, you are writing this x naught cross y belongs to this ui cross bi. In general you are writing, and here you have to write for some I. Why you are saying for some I? Because this is union, right? So union means it is not necessary to have that particular element in all these basis elements, because it is union, right? So it is enough to have the particular element in some basis elements, or one or two basis element is also okay, because when you find the union you will have this element, that, right? So that is why you are putting for some. In short, I can say for some I you are writing, because here you are having union. That is why if there is intersection you have to write for all I. Okay, so I hope this step is clear to you. Then therefore we get x cross y belongs to, instead of x naught cross y you are putting x cross y, because x naught belongs to capital X, this x is also belongs to capital X. So instead of x naught you are putting x. Okay, x cross y belongs to ui cross vi, the same step, only difference is in the place of x naught you are putting x. And next what you are writing is, that is, in the next step you are getting x naught cross y belongs to n. Why? I will tell you why. You have this in the third line of the proof. You will write you will cover this slice, right? You will cover this slice by this basis element u cross v, and you will say this u cross v intersect our product space, and then you will write what? You will write what? This u basis element is contained in n. That sentence you will write. So what you are knowing, this basis element is present inside this n. Okay, that you will know from this line. So that is why you are writing basis element present inside n, that you have in the third line. So using that you can write x cross y belongs to n in this step. Now you have in here you have took x cross y belongs to this, but finally you are getting the same x cross y belongs to n. So from these two you can say w cross y contained in n. So you have proved the two conditions to to prove the statement of tube lemma. So finally the proof of the tube lemma comes to an end.